Unit 3 review. Okay, so we're talking about differentiability in this first one. I think we had this exact problem on our homework. Excuse me. So it wants to find f prime of 0, so we're going to go so when I plug 0 in, I'm going to get a 0 in the denominator. Undefined, which means not differentiable or vertical tangent. Using your graphing calculator, you can see the sketch. Looks something like this. And there's just a dramatic change in these slopes. The slopes here don't match up the slopes here. Okay. Similar type of problem with number 2. If I plug 2 in, undefined, and why is it undefined? Why is it not differentiable at 2? It's because it's not continuous at 2. Alright, now we got 4 problems where we have to take the derivative. Recognize this as the definition of derivative, which means I really just want the derivative of this function. Recognize this once again as the definition of derivative, which tells me I just want this. If you wanted to clean this up, negative 2/3 puts me at the cubed root of 2x squared. This is the same as the derivative, except for it's asking for the derivative at pi over 4, so I go pi over 4 here, and that's a little bit easier to see it on this one than this one. That's why I went in this order, because this is the alternative form of derivative. Here they've got sine x minus, this is the same thing. I want the derivative of sine x and then plug in pi over 2. So the derivative cosine x, and then I want pi over 2, so cosine of pi over 2 is 0. Okay, don't be fooled by the notation. This is the slope of the tangent line. This is the derivative of this function. So it wants us to know the normal line equation, so we got to find x by setting our derivative equal to this, and then plug it into the original to find y. So dy dx equals 2e to the 2x. Okay, remember that the derivative of e to the 2x is e to the 2x times the derivative of the inside, which is 2. So we set this equal to 2. So divide both sides by 2. Natural log of both sides. So I get 0 equals 2x. Therefore, x equals 0. Then I need to find my y, which is e to the 0, so y equals 1. I've got x, I've got y, I've got slope. So y minus 1 equals 2x minus 0. So y equals 2x plus 1, which is a. Oh, no. I'm sorry, normal line. So it's going to be negative 1/2. Negative 1/2. Here's my slope of my tan. So the normal slope is negative 1/2. Of course, that would be A. I did this problem before, and the thing didn't record correctly, so I went a little too fast. But I knew the answer was A, which told me I made a mistake. All right. So we've got e to the x squared, so we've got a product rule here. We're going to find the approximate value of 1.1 if we use the equation of the tangent line. If I went, just to show you how close these two are going to be, if I went f of 1.1, I'd got b. If I'd have just plugged 1.1 in here and got the exact answer, I'd got this. Okay? Don't make that mistake. It's not what it wants. It wants to know f of 1.1 using the tangent line. So we've got to first find the derivative. Product rule, derivative of x squared is 2x times e to the x. The derivative of e to the x is e to the x times x squared. I'm finding the equation line of the tangent line at x equals 1. Therefore, m equals 2 times 1, e to the 1, plus e to the 1 times 1. I need to plug 1 into my original to find y. E times 1, which is e. So my slope of my tangent line, or my tangent line, is y minus e equals 3ex minus 1. So that's 3ex minus 3e plus e equals negative 3e plus c is 3e to the x minus 2e. So I want to know x equals 1. So this is 3e minus 2e, so this is just e. The value of e is 3.534 in your calculator, of course. Oh, I'm sorry, I put 1 in for x. I did it again. Alright, so it's 3e to the x. Shoot. That's what happens when I hurry, because I've already done this once. 3e to the times 1.1 minus 2e. Now let's try it again. The answer, of course, is going to be A. 3e times 1.1 equals minus 2e 3.533. Okay. Sorry about my mistake. Don't do the same thing. Alright, so it looks like we got some chain rule here. F of x is 5 cosine squared. 2 times 5 is 10 out front, times cosine to the first, times the derivative of cosine, which is negative sine, times, this is all multiplied now, don't forget, times the derivative of the inside, which is negative 1. So before I go anywhere else, I'll get rid of those. So I've got 10, we're putting in pi over 2 times cosine. Pi minus pi over 2 is pi over 2 times sine of pi over 2. Cosine of pi over 2 is 0, so 0 times 10 times 1 equals 0, which is A. So what values does this have where the normal line has a slope of negative 1/5? So with the tangent line slope, so I don't make the same mistake I did here, is positive 5. So I'm going to set and find k by putting in x equals 1. So equals k times e to the 2x times 2 plus 3. Putting in 1 k e times 2 plus 3. Okay, and this value is going to be equal to 5. So 2k e squared equals 2. K e squared equals 1. K equals 1 over e squared. Number 8. Give me 1 second. Okay, what type of polynomial function is f of x? Well, this is a cubic function. Oh, wait a minute. I'm sorry. You got to read the instructions. The graph of the first derivative, f prime of x, of a polynomial function f of x is pictured to the right. So this is a cubic function. So therefore, f of x must be a function of degree 4. Okay. Because the derivative goes always 1 degree less. So I would say this, ax to the n, then what values of f of x have horizontal tangents? Okay, horizontal tangents. Alright, so so this is f prime of x, so horizontal tangents occur at these zeros, 1, 2, 3, so x equals negative 2, 1, 3, because prime of x equals 0, I want interval where my original graph be increasing wherever this is above the x-axis, so between -2 and 1, and between 3 and infinity. Because f prime of x, this is all you need to know, is greater than 0. Decreasing, you'll need to know this as well, because f prime of x is less than 0. So where does that happen? Negative infinity to -2. And 1 to 3. Find two values on the interval 0 to 2 pi where the slope of the tangent of the graph of f of x is equal to, so slope of the tangent line is equal to square root of 3. So take the derivative, set the derivative equal to square root of 3, and solve. Derivative of cosine is minus sine. Don't forget the chain rule. Derivative of 2x is that, so -2 sine 2x. And we're going to set it equal to square root of 3. So we divide. So I get negative square root of 3 over 2 equals sine. So this is a little bit tougher. Sine of 2 theta. Where does sine equal? Where does sine equal here? All right. So we're looking for this angle. All right. Normally we would just have sine of theta here. Now we've got this. Where does sine, my y value, equal square root of 3 over 2? Is it? Okay. So here my point is square root of 3 over 2 1/2. Here it is 1/2 square root of 3 over 2, negative 1/2 square root of 3 over 2. So we're talking about the 60-degree reference angles, which is pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And sine is negative in these quadrants. Okay? So we're talking about this. So this angle, this whole piece, is equal to square. So I've got to set 2x equal to these two. 2x equals 4 pi over 3. So 1x will be equal to 4 pi over 6, 4 pi over 6, which is 2 pi over 3. And then 2x must also equal 5 pi over 3. So one other x is 5 pi over 6. So a little bit tricky. Don't let that throw you off if you see it on a test. You know that. Alright, last one. Consider, I think, no, there's 2 more. Consider the piecewise function. What has to happen at this to be continuous? Limit as x approaches 2 from the left of f of x must be equal to the limit as x approaches 2 from the right of f of x. Gives me values for a's and b's, so I'm going to plug in 2, a, and b for this, and x, a, and b for this, and set them equal to each other. And all we're doing is seeing if they're equal. So -3, and then x is 2, plus b is 4 times 2 plus 2. 2 squared is 4, -12, plus 8 plus 2 is -2 over here. A is negative 3 times 2 plus 4. Negative 3 is at, boom, so it is continuous, yes. Differentiable, so we're going to differentiate and plug in our numbers and see if they're equal. So 2ax plus b must be equal to a. So in this case, a is negative 3. 2, negative 3, 2 plus 4. It's 4 times negative 3 is negative 12 plus 4 is negative 8. No, not differentiable. Alright, so now it wants to know what values will they be both continuous and differentiable, so we're now going to have to set up, this means set up your system. Equation number 1 is going to come from the limits. So we're going ax squared plus bx plus 2 equals ax plus b. And at x equals 2, so 4a plus 2b plus 2 equals 2a plus b. Let's get all the a's together. 2a plus 2b, plus b equals negative 2. So there's equation number 1. Equation number 2 comes from differentiating both sides. We already did it up here. I get 2ax plus b equals a. And we're talking about when x equals 2. So 4a plus b equals a. So 3a plus b equals 0. This is equation number 2. Change the signs at the bottom. Negative 2. B's go away. I get negative a, so a equals 2. I'll plug it in right here. B equals negative 6. Last one.
Can you make it so I can get on my practice test?
Yes, if you give me about 5 minutes.
All right, sir.
All right. Find the value of h prime using capital H of using, explain what this is. Spins a lasso in a circle perpendicular to the ground. The height from the ground. Alright, so we're going to plug this into the calculator. I'm going to do this whole thing in the calculator. We can certainly find this derivative. Y'all are very good at it. Especially you, Dane. Alright, so we can go math. Oh wait, we just want the value of h of 7.5. Well, the height from the ground is measured and modeled by the function h of t. So h of t is going to be the height of the rope after t is number of seconds, t seconds. So h of, so after 0.75 seconds, this is negative 3 cosine 5 pi divided by 5 pi times 0.75 divided by 3. Let me insert some parentheses in here. just to make me feel better about it. .1213. So after 3/4 of a second, it's 7.1 feet off the ground. This is the value of this. So if this is the height off the ground and it is rising and falling, this is the rate that the knot, this is the rate of change of the height over time. So this is the rate the knot is either rising or falling, okay? Depending, because it's a trig function, so you know it's going to go up and down. So I'm going to go math 8x. I don't know if I can get lucky and no, I can't. Alright, so math 8x -3 cosine 5 theta divided by 3 plus 5. X is equal to 0.7. Oh, we don't have to do it. We can just use x here. X is 0.75. And that's equal to 0. So what happens with either a maximum or a minimum? So the rope is either, so the rope, as his lasso's in a circle, right? There's a knot somewhere on it going. So he's either reached his maximum or minimum. We would have to test points to find that out.